All right, this is going to be a quick video to go through a few problems from your dimensional analysis practice from 1.4, just in case you missed class or if you need some clarification. And then at the start here, I want to remind you that while some of these conversions that we're going to do, I'm sure you could do them either some of them in your head or on your calculator or in a different method. That's great. And normally we encourage you to find different ways to solve problems and be creative. But please realize that the reason that we are having you do these particular calculations is because A, they are relatively easy, but B, we're using those calculations as a vehicle for which or with which to teach you dimensional analysis. We want to teach you this skill now so that later when we're doing things like the mole and stoichiometry, we're not having to teach you stoichiometry and dimensional analysis at the same time. So the emphasis is really, really on showing your work, canceling units, and doing it in the way that we are teaching you now. If you have another way to solve the problem, that's fantastic. That's great. We are very proud of you, but please solve it this way so that A, we can give you credit, and B, you're prepared for the harder stuff that's coming later. So we're asking for a little bit of trust in this. So let's go through some practice problems. I'm going to pull just a random smattering from that list and try and hit on a couple different bases. So I'm going to start with number 1. Okay, so we've got 16.7 inches, and I want to know how many yards that is. Okay, what you need is a conversion factor. In other words, an equivalence between these units. To make it as transparent as possible, I'm going to go from inches to feet and then feet to yards. You could go straight from inches to yards, but the purpose of this video is to really teach you the skill. So I'm going to break it down as much as I can just to give you that extra help. So here are my conversion factors. In other words, here are the things that I know that are true. I know that there are 12 inches in 1 foot, and I also know that there are 3 feet in 1 yard. And I'm going to use these facts to help me convert between those units. Okay, so I'm going to start with my measurement. Now, as a side note, my measurement here, 16.7 inches, this is the only place that significant figures is going to come from. My conversion factors do not factor in to, I said factor twice, hate that. I'm going to say it again, factor into significant figures because these are facts. It is a fact that there are 12 inches in 1 foot and a fact that there are 3 feet in 1 yard. I don't need to measure that. The only measurements have significant figures. So I know already my final answer will need to have 3 sig figs. Okay, and I'm going to set it up so that I cancel units. That's my goal. If you are in Mrs. McKinney's class, she might use the railroad tracks where she draws it all the way out like this. That's totally fine too. This is just my habit, okay, whichever one works for you. So my whole goal is to cancel units. I'm not worried about numbers right now. I'm not worried about my calculator. I'm just worried about making inches go away and any other unit go away until the only thing I'm left with is yards. Okay, so I'm going to look at my conversion factors, find one that has inches in it. Boom, there we go. 12 inches equals 1 foot. I'm going to put 12 inches on the bottom of this fraction. All right, my goal here is to make inches cancel. So I need one in the numerator and one in the denominator. So that makes that happen. Remember, 16.7 inches, that's just a whole number. So that's going to be in my numerator. Okay. Now 12 inches is equivalent to 1 foot. So I'm going to put that up here. Now, if you're a very visual person, maybe you would like to do something like cross off the conversion factor that you've already used so you don't try and use it again. Okay. If I pause and look at this, the unit that I am in currently is feet, which is great, but I need to keep going and go all the way to yards. So I'm going to do another conversion factor. This one says for every 3 feet, that's equivalent to 1 yard. I know it's not rocket science. I know you know that, but again, we're practicing the technique. I'm going to put 3 feet on the bottom and 1 yard in the numerator. Okay, feet will cancel. I am left with yards, which is excellent news. That's what I was looking for. So I know that I've at least set it up right. I still need to plug it into my calculator, but I know that I have set up myself for success. Now, when you have numbers in the denominator, you divide by them. Numbers in the numerator, you multiply. If you really, really wanted to, in your calculator, you could go 16.7 times 1 divided by 12 times 1 divided by 3. I know what happens when I multiply by 1 or divide by 1 for that matter. So I'm just going to go 16.7 divided by 12 divided by 3. 16.7 divided by 12 divided by 3. I welcome you to plug that into your calculator. So pause me really fast if you have your calculator on hand. Unrounded, I get 0.463 and then a whole bunch of 8s. Okay. But I only get 3 significant figures. 1, 2, 3. The 8's going to round up. So my final answer would be 0.464. And then my unit would be yards. That would be my final answer there. Okay. I'm going to jump to number 2. Right. Number 2, we're going in the opposite direction. We have 25 yards. I'm starting with yards this time. And I'm going to go to inches. Now, why am I covering a problem that's very, very similar? I will show you momentarily. Okay. Coincidentally, I'm going to use these same conversion factors. You don't have to write them out if you don't want to. If it helps, do it. If it doesn't, if it just gets in your way, then don't worry about it. I am only worried about getting rid of yards, and I'm not going to stop until I'm in units of inches. So for every 1 yard, putting on the bottom so it cancels, I know that's equivalent to 3 feet. All right, yards are gone. I'm not done yet, though. I need to get all the way to inches. So for every 1 foot, it's the same thing as 12 inches. All right. I know I've set it up correctly because my unit that I want is in the numerator. All right. That's the only unit that's left. I get to keep 2 sig figs. Okay. And here's why I wanted to do this problem when I'd already done this one. They're the same thing, just backwards in terms of their setup. Notice that up here in problem 1, I had my 2 numbers in the denominator, so I divided. Here, I'm going from a bigger unit to a smaller unit. My numbers end up being in the numerator. My numbers that aren't 1 end up being in the numerator, so I'm going to multiply by them this time. Number 1, I divided. Number 2, I multiplied. All right. You don't need to remember that, though. You don't need to remember, oh, when I go from inches to yards, I divide, and then vice versa down here. Just set up the dimensional analysis, and then the problem itself will show you that. If the numbers are in the numerator, multiply. That's all you need to worry about. So I'm going to go 25 times 3 times 12. I get to keep 2 significant figures. Oh, we get tricky because we end up with an answer that is 900. That's 1 significant figure. If I add a decimal at the end, that's 3 significant figures. And of course, the trick is to use scientific notation. So that should be 9.0 times 10 to the second. That has 2 sig figs right there. And then my unit is inches. Okay. So I wanted to show you 2 kind of contrasting examples. Let's do kind of a behemoth of a problem. I'm going to skip to number 5. In 5, we have 48,987 minutes. And I want to know how many years that is. Now, off the top of my head, I'm going to guess that however many years it is, I don't want to have been alive for this long. This sounds too long. 48,000 minutes sounds like too long. Let's find out, though. Because remember, they're the same, right? Just like 25 yards and 900 inches is the same. Just measuring it differently. So let's dive in. I'm going to start with minutes, and I'm not going to stop till I get to years. 48,987 minutes. Okay, I know that there are, canceling the unit, 60 minutes in 1 hour. I'll start with that. Let's see, minutes are gone. I'm now dealing with hours. I also know that there are 24 hours in 1 day. Okay, I can keep going with that. And then I also know that there are 365 days in 1 year. And I don't want to hear no nonsense about leap year and whatnot. I'm going with 365. I'm going to call it good. Days cancel. All right, I'm left with years, which is perfect. Notice, again, I've done no math up to this point. I have just set up my problem, and it's going to tell me what kind of math I need to do, whether I need to multiply or divide. In this case, all my equivalencies, all these numbers that are not 1 are on the bottom, so I'm going to divide by every single one of them. I get to keep 5 sig figs, which is a lot of sig figs, so good on me. 48,987 divided by 60. If you really want to, multiply by 1, times 1, divided by 60. Times 1, divided by 24. Times 1, divided by 365. Okay, I get to keep 5 sig figs. So it's going to be 0.0932. That's 3 sig figs so far. I get 2 more, 0, 2, and then my unit is years. It turns out I was way wrong. Okay, I thought that this was way too many minutes to have been alive. It's not even a tenth of a year. So I maybe need to adjust how I perceive time, because I'm very happy that I've been alive longer than a tenth of a year. My daughter's been alive longer than a tenth of a year, for crying out loud. All right, that's how I proved it to myself. So I've learned something. Last one. Again, I'm skipping and just pulling a random smattering to give you some good examples to work from. This one uses the metric system. We love the metric system. Yes, we do. So this says, all right, we've got 60 kilograms, and I want to know how many milligrams that is. So this requires you to have a good understanding of the metric system, which you should have by now. But if you don't, go ahead and pull out your notes. You should have the order of the prefixes. So, you know, kings have diamonds and diamonds cost money, except, you know, something else about chocolate milk. I don't know. I'm going to show you 2 ways to solve this problem. And either way is perfectly acceptable. You can either break it down into 2 steps, or you can do it in one giant step. My brain, I prefer to break it down into 2 steps because I have everything about the metric system memorized with respect to the base unit. Okay. Yeah, I can figure out how many milligrams are in a kilogram, but I prefer to actually just break it down and go from kilograms to grams and then grams to milligrams. So here's how I would do it, because this would be faster for me, just the way that my brain is programmed. I know that in 1 kilogram, there are 1,000 grams because I've memorized that, because I've done it a lot of times. All right, so now I am talking about grams, not kilograms. And then I also know that if I take 1 of those grams, it's made up of 1,000 milligrams. Okay, so grams cancel. I already canceled kilograms. Now I'm dealing with milligrams, which is what I want. So this ends up being, I only get 1 sig fig, which is fine. That's going to be 6 times 10 to the 7th milligrams, or I believe that's 60 million milligrams. Either of those answers is perfectly acceptable. Now, if you don't want to break it down into 2 steps, that's okay, if you know how many milligrams are in a kilogram. So you could do it this way. So this was option A. Here's option B. You could be like, I'm better than Miss Grant because I have all of this memorized, and I know that in 1 kilogram there are, so you have to think about it, 1 times 10 to the 6th milligrams. If you know that, fantastic. You just saved yourself, I don't know, a little bit of time, maybe. Kilograms cancel, you're going straight to milligrams, all right? And you are going to get the same exact answer, okay? Now, you could be even like, hey, I could have just done that in my head and not bothered with this at all. Yes, I'm sure you could, and that's wonderful. But remember, the point is to show all of this work, to learn this technique now, so that later when we're learning stoichiometry and the mole and all this other fun stuff, we are not stressing about this and the new stuff at the same time. A little bit of faith, and it'll work out in the end. Just trust us.